Hi there again, Pre-Calcers. Time for another online lesson, this time on 5.4 applying trig functions. In class you're going to be working with a partner and presenting kind of a real-life application of these things, so we'll give you some of the bare necessities on this, which you may have seen already before. So let's say we have just a particular triangle like this, and we're going to say that this side is 12, it's a right triangle of course, that this angle is going to be 50 degrees, and we're going to try to find the hypotenuse, which we'll call r. How do we do that? Well, the right triangle trig functions can be very helpful here. The thing to look at first of all is kind of basing ourselves on this angle right here. Notice that the two sides we're interested in are the opposite side and the hypotenuse. And so if you ask yourself which of the trig functions talks about opposite and hypotenuse, you would remember that it is sine. So I'm going to set it up like this. It's always the sine of an angle. So the sine of 50, and sine once again is opposite over hypotenuse. So in this case it's going to be 12 over r. This is a bit cumbersome because my r is in the denominator. If it was in the numerator, I could easily multiply by what's in the denominator and have my answer fairly quickly. But in this case it's a little tricky. So here's a nice little trick that I think we're going to use a lot of times. I'm going to just interchange the sine of 50 and r. So it's going to look like this. And the reason I can do that, you may remember when you have proportions here, if I wrote this even as a fraction, the sine of 50 over 1 equals 12 over r, that if I would normally solve this by cross multiplying, sure enough I'd get r times the sine of 50 equals 12. I would then divide by the sine of 50. The bottom line here is that when you have a proportion, you can interchange the kitty corner parts, which is essentially what I did here, and you'll still be able to get the same answer. Alright, so getting back to our answer here then, if you do this in your calculator, again make sure your calculator is in degree mode, you should get approximately 15.7. So that's what r would equal. Alright, so far so good. Problem. This one just slightly different. I'm going to change pen colors here for fun. So again, we have a right triangle. This one, let's say we have 13 miles for that side and 8 miles for this side. We're going to call this angle C right here. And I'd like to know, what is the measure of that angle C? What's the measure of that angle C? Well, once again, notice that in this particular right triangle we're given the adjacent side, to angle C anyway, and the hypotenuse. Which trig function talks about adjacent and hypotenuse? Well, it's the cosine part. So cosine of C will equal 8/13, like that. And so then how do I figure out what C is? Well, when you're looking for the measure of an angle, that's when you need to use the inverse cosine, which you'll find on your calculator. The second in cosine looks like this. And then when you do the inverse cosine, you'll always get an angle. So in this case, I take the inverse cosine of this 8/13, and sure enough, if you're in degree mode, your answer that you get should be about 52 degrees. So that's a little different. We still set it up the same, but then when you're looking for an angle, you'll need to use that inverse function on your calculator. Alright, here's another concept that comes into play, the angle of depression and angle of elevation. And angle of depression is always looking down, so generally you're on some kind of a high point like a building or a plane or something like that, and you're looking down. So the angle of depression always formed from that line, from that object you're looking at, to a horizontal line which should be even with the level that you're at. The angle of elevation, on the other hand, is looking up. Again, usually one of the sides there would be the ground level, and then again you have that sight line looking up to some high thing like a plane or a balloon or something of that nature. And the nice thing that you'll use in some problems is the angle of depression and the angle of elevation. They are often equal. They are often equal, because what kind of angles are these? If you remember from your geometry days, those are called alternate interior angles. And if you have an alternate interior angles and the two lines that help produce them are parallel, as they would be here with the ground level and a horizontal, then those alternate interior angles are congruent. Alright, problem related to that. So let's say we have some observer here, and top of a lighthouse, there it is right up there, and the angles of depression to two ships. You only see one ship there. I'll see if I can draw in my other ship here. There it is right there. Nice looking ship. And so your angle of depression are to two ships are 3.5 degrees and 5.75 degrees. So again, where those two angles are coming from would be right here. So one of those angles is going to be the 3.5 degrees, and then the other angle, which I'll get a different color here, which would be going down to this ship, this would be the one that's going to be a little bit bigger, and that's going to be the 5.75 degrees. So we're ultimately trying to find how far is it between these two ships. So I think one thing that'd be kind of good to do is to draw these two triangles. I'll try to draw this green one here first that has that bigger angle of depression. So do you see if I actually drew that angle to where that little ship was? Certainly this would be the 125. That's how high the lighthouse is. Now the 5.75, remember, that's out here someplace. That's that angle of depression. So really the angle that's going to be right in here should be 90 minus that. So this is going to be 84.25 is what that'll end up to be. And remember, I'm really looking for this particular distance here. How far will the lighthouse be from that ship? Well, again, if I'm trying to find that distance, notice what I've really been given here, especially from this angle. I don't really need to know what this angle is necessarily, but notice from here I have opposite, from this angle here, from this angle here, I am looking for the opposite side, and this is the adjacent. So which of the trig functions talks about opposite over adjacent? Well, sure enough, it's tangent. So I'm going to say the tangent of 84.25, kind of running out of room here, equals D1, which I'll call that, over 125. And I'm going to multiply each side by 125. So I have 125 times the tangent of 84.25. And sure enough, that's going to equal 1,241 feet. That's D1. So we'll keep that in mind as we go to our next calculate this other triangle. So I'm going to use a different color than brown. I think that wasn't too smart to use that. So now my other triangle, which will be based on this angle right here, is going to be okay, here we go. So we're looking at this other triangle here now. So again, this was the 3.5 degree angle of depression, meaning that now this angle that we're really interested in to draw this triangle is going to be 86.5. Those two would have to add up to 90. We still have our lighthouse at 125, and this time I'm going to call this D2. Same setup as before. I'm going to use tangent once again. So the tangent of that 86.5 is going to be D2 over 125. And again, just to solve this, it's going to be 125 times the tangent of 86.5 will give me D2. And if I do that on my calculator, I get 2,043. So the ultimate question, though, was how far apart are the ships? Well, if I take my D2 minus my D1, then I should be able to find that. And if you remember what that was, here's our distance. Second distance was 2043, and my distance from the previous slide that I figured out was 1241, and so my actual answer then would end up to be about 802 feet apart. So that's kind of a sophisticated problem, but you'll get one like that when we do a test on this chapter, certainly, where you have to understand what that angle of depression and elevation might mean, and be able to draw some diagrams and use some right triangle trig to figure that out. All right, very good. Thanks for watching, everybody, and we'll see you in class.